So I think it's better that we go ahead and get started. And people can drift in as they like. So with us today, folks, welcome. This is the Amplifying Her Voice panel on global trends in space. My name is Zahir Ali. I will be moderating. With me is Dr. Chimeret Mamanam, Professor Babatunde Rabiu, Mr. Mishak Kinyua Nduruti, and Mr. Aravind Ramachandran. We have a couple other panelists who hopefully will be joining us shortly, but seem to have been slightly delayed. And in general, we're going to be looking at what's going on around the world in space, particularly in some of the smaller economies and developing nations who represent what is perhaps the greatest opportunity in space. And we're going to get going just shortly here. Let's just give folks a couple more minutes to drift in, and then we'll get started. I see that we're getting a few more people joining in here, and I believe I was seeing some chatter that the other session is wrapping up now. So we're going to get going here. Okay, well, thank you everyone for joining us again. This is the session on global trends in space. And we're going to get started with Professor Babatunde Rabiu. He is a professor of space physics and has been the director and chief executive of the Center for Atmospheric Research of the National Space Research and Development Agency in Nigeria. He's watched several decades of the space economy evolve during his lifetime. And I would like to start off with you, sir, and ask you to comment on what you've seen in your career, fundamentally, as a witness to multiple eras of human endeavor in space. How do you see the opportunities in space changing now, and what is different now than even 10 years ago, particularly perhaps for developing nations? Professor Babatunde, we'd love you to lead us off with your comments and thoughts on that question.
Okay, thank you very much. Okay, yeah, thank you very much. Sorry, opportunities that the space program has created in recent times in developing nations. I speak with respect to Africa. Fortunately, I've been privileged to be within the sector in the past 3 decades, precisely about 31 years ago when I just finished my college education in 1990. So I've seen a lot. Now, let me talk about the opportunity for African scientists to get involved in space research. More than ever, there have been a lot of global opportunities in recent times for African research to participate in global research opportunities. And before now, there were no facilities to do ground observations. So in terms of infrastructures, ground infrastructures for research purpose, the African community, African nations, and other developing nations have actually come to benefit tremendously. For example, this week, we are hosting an international conference that has to do with GNSS and opportunities and research in Africa. And this is done, it's been hosted by United Nations Office for Outer Space Affairs in collaboration with Kenya government. And today, I had a 1-hour lecture delivered, and we had over 100 participants with more than 80 of these participants from African continent. So more than ever, we have opportunities to do tremendous research in space, in space studies, and this is evident nowadays in terms of our research publications outlook. If you go online, you will see that there are more authors from African countries in space-related science and studies. Now, come to space applications. Some few African countries now have dedicated space commission or space agency that are busy developing space programs in their countries. Nigeria developed the first space agency. South Africa developed the second space agency. Now we have Kenya coming up. We have Ghana. We have Egypt. We have Algeria. We have some other African countries coming out. Even the African Union, as an entire body, has also gone ahead to develop African Space Agency, and the headquarters has been domiciled in Egypt. So this is a huge, tremendous development for Africa, and the African nations, some African nations, including Nigeria, of course, are using space products to provide good governance and also to mitigate disasters and to control, that is, natural disasters in their regions. Nowadays, there is military warfare going on in a number of African countries. My own country is not spared of this crisis. But I tell you that the African military officers, the African military systems are also using space technology in battling in carrying out the warfare against the terrorists or militants. For example, Nigeria as a nation today has equivalent of military space agency. We call it Defense Space Administration. Defense Space Administration. So there we have the Nigerian Army, we have the Navy unit, we have the Air Force, we all combine together, and they are using space technology and applications in carrying out their military responsibilities. And there is tremendous progress in this regard. And so they fight both from the space environment, that is, they use satellite imageries, and they use appropriate navigational technology and in carrying out their assignments. So outside this, there are a lot of things happening. I've mentioned the research infrastructure for research program, and again, in terms of popularization of space activities, some things were in our traditional settings in Africa. Some things were looked at like myths. Some things were looked at as if they are not scientific. When it comes to space program, like when you have solar eclipse, some people want to see it as an omen that maybe something bad would want to happen. But nowadays, and in developed countries are coming to have understanding of space activities more than ever, and they are now differentiating between what activities are or some phenomena are. They are not just that can make people to want science. More because we're looking at the trends, the way the things are really changing. I want that the global corporation, the international corporation, has brought the privileges, has brought the applications, has brought the dividends of space programs closer to developed nations more than ever.
Interesting.
Yeah. Okay.
So it's not just government, sir. It's also industry that's bringing this. So thank you for those comments. That really sets the stage for the discussion. I want to invite our other panelists, perhaps, to chime in and comment on the professor's remarks. Perhaps Dr. Maman or Arvind, if you given your backgrounds, how do you see that evolving for Africa? Please, would one of you like to chime in? Dr. Maman, I see you're off mute, so go ahead.
Well, first of all, thank you so much for having me on the panel. It's a great opportunity to meet you all. I think that Africa is on the right path. With the South African Space Agency coming along, and with all the miniaturization of the nano satellite and those projects going on, it does seem like it's a big challenge, but everybody needs to see this as a great opportunity. I could tell you that we have a really great group of girls from Togo working with us on an international project, which is called She Space International. And we're actually using satellite imagery to teach these girls how to confront climate change issues. So they're investigating using satellite images. And usually in this program, we ask each of the participating countries to share their own data from their own country. As Togo does not have their own satellite, so these girls are using Landsat for that matter. But even though using an American satellite for the purpose of studying the climate change effects in Togo, this brings a really great sense of achievement and capability to these young girls and shows them what they could be and what they could develop into. So we find that I find that everybody there is really on the right path to success.
Wonderful. Thank you for your comments. Arvind, you were coming off of mute, so I want to give you a brief comment on that if you like before I move on to the next question.
Yeah, no, thanks for the opportunity and thanks for the question. On Africa, I've worked with quite a few people who are working on a number of projects, especially on, I think, Professor, he touched on a lot on the upstream side of things. And I wanted to, just like Dr. Maman looked at the downstream side, there's a lot of satellite imagery available today. And actually, there's just too much that has been underutilized. And where I think Africa is one of the countries, I think, where there's a lot of potential, because one of the biggest uses of satellite imagery is environmental monitoring and monitoring natural resources. And I don't think you can see, a better use case in, a different part of the world than in Africa, because there's a lot of monitoring to be done. And the fact that you don't have local infrastructure means that satellites are the only way to monitor. You don't have sensors installed if you want to monitor pollution. You don't have, other types of sensors to monitor temperature or other types of natural variables, and satellites provide the best way for us to do that. And there's a lot of potential there. And both from she mentioned Landsat, which is the institutional side, and from Europe there's the Copernicus program, and there are initiatives like Digital Earth Africa, which I've worked with, which is a very interesting initiative, because it's basically creating a digital map, a digital twin of Africa that people can use to, develop applications for agriculture, develop applications in forest monitoring, in weather. So there's a lot of applications on the downstream side. I think that's for me, the most exciting side. Of course, the space side, building the satellites is, there are a lot of countries investing in that. But I also think there's a lot of value yet to be extracted on the downstream side, on the application side. And I think that's what's super exciting for me in the next few years, at least for Africa.
Thank you, Arvind. And that's Arvind Ramachandran of who's demystifying space technology at TerraWatch Space. So very much providing us on this panel business perspective. I want to come back though right now to Dr. Shimrit Maman, and let me introduce her properly this time, who's director for the Earth and Planetary Image Facility at the Ben Gurion University of Negev, and is an expert with experience both in remote sensing, earth science, and fundamentally applying space assets to do interesting things. And given being that you are in Israel and Israeli, I'd really like you to share your perspective on what has contributed to Israel's success. I think a lot of developing countries, smaller economies, look to Israel as an example of what can be done with limited resources, but innovative and a can-do attitude culture. So we'd love to hear from you. What parts of that model have led to success, and what lessons learned could you share with us?
Yeah, that's a great question. Well, I think that basically what brought us to the place we are today as a startup nation is necessity. Okay, and that is something that everybody has to understand. We're dealing with a very delicate political situation, and by being so, you have to be very creative. So the downside is that sometimes we suffer from certain things, but the upside is that it does bring certain amount of creativity that enables things that are very high and advanced, high tech for that matter. So if we have everybody launching to the east, okay, in Israel, we have to launch to the west. And in order to do that, there should be a reduction in fuel, and therefore our satellites are smaller in size. So you could look at it as the beginning of the new age era that we started 4 decades ago. And the global trend is now going towards this miniaturization of satellites. What I love most about the possibilities in Israel is that we dare to dream very big. We are a very, very small country with a can-do attitude, as you said, Zahil, but with a very, very high capabilities. I would add an Hebrew word, which is called chutzpah. Yes. I don't know if you're familiar with that.
Oh, yes.
But that's a very, very Israeli attitude that is very daring and a bit I will say not politically correct. And that would bring 3 people just sitting up in a bar, sketching down and saying, okay, you know what? We're going to go to the moon. And a decade later, they went to the moon, and they brought the whole Israeli state to be the 7th country to orbit the moon. So we dare to dream. We dream big, and basically everything that brings us to be creative is we don't look at it as something bad or something depressing. We look at it as a challenge. And that's how we treat things here.
No, thank you. And, I want to invite Mr. Mishak Nduritu to comment on that, because, he is a space technologist. He's a leader in space applications at the African Union. So coming back to the concept of necessity driving this, and having the chutzpah to really go after, that irreverent daring, perhaps might be a English definition. Why not us? Why not now? Certainly, this next century could be the African century, and I would invite Mr. Nduritu to comment on the applications that you see, being relevant for Africa right now and in the future, and how we can capture all the value possible from what's already up there and what's going up there soon. Mishak, are you able to come off of mute? Oh, it looks like we've lost him. Perhaps I can bounce that back to Professor Rabiu in terms of applications. Could you comment perhaps on some of the recent applications you've seen applied in Nigeria or other African countries? I know you mentioned a couple earlier.
Yeah, when you talk of applications, because I'm practically a space physicist and get involved in a lot of research work. We use GNSS data. We use those GNSS systems to study data from there, to improve the navigational systems. But with respect to applications of space technology for disaster monitoring, the African nations have disaster monitoring satellite system, and we share data. There is this system of satellites that is made up of a constellation of satellite systems from Nigeria, Algeria, Egypt, and the satellite imageries are shared among the countries used for disaster monitoring as well. So I must say, as mentioned earlier on by one of the speakers, that Africa is actually making use of satellite imageries to solve their daily problems more than ever. However, I know that we have some restrictions because Africa is made up of 54 nations. Right. And it's not just one country. And each nation is sovereign, each nation is autonomous. So the problem we probably have is that maybe less than half of the African nations are actually using space technology and to solve their problems. But our joy is that the African Union has stepped up the game by establishing an African system, such as the African Space Agency, and they are also looking at the way by which the African governments, African states, can incorporate space technology into their governance systems. I know of Nigeria, there are lots of benefits that we are deriving right now using space technology, and then using space technology to drive our ICT, and using the space technology via ICT to drive our economic systems, the financial systems in the country. And that is making it very possible for government to detect a lot of corruption going on. And yeah. So if I tell people nowadays that when the government, people that are afraid of space technology are people that are very corrupt. We're not one, because space technology provides no hiding place for corrupt people, because when you apply appropriate ICT, when you apply this to your banking systems, to daily financial transactions that has to do with government, everything becomes transparent. So it promotes in governance, in financial transactions, and so there are numerous applications, I must tell you this. So that's it.
Well, that's spectacular. Thank you. It looks like we keep losing Mr. Ndiritu. We'll have to invite him back for a solo interview. That's what's going to happen to get his perspective, because I was hoping to ask him about the African Union. But maybe I could bounce this over to Aravind. One of the to provide perhaps a business opportunities perspective on those applications. Yeah. Because and Dr. Maman, I'd love you to chime in. Kind of, you gave an overview, but maybe you could even after Arvind's commented, talk a little bit about some of the economic value specifically, as opposed to the governmental use that Israel has derived. But Arvind, you've got a very wide view. What do you see there in terms of the economic benefits that developing nations can derive?
I mean, I've been part of a lot of studies, for example, with the European Space Agency and the European Commission on what is the return of the return of investment in space technologies, and what's been the let's say if you invest €1 into space, what is the return that you get? And I've been part of studies, and I've been absolutely surprised myself in terms of the return, because obviously you don't really see the benefit. And you can look at I've worked on return on investment for launcher programs. So if you invest in a launcher, what is going to be the return? And it turns out that it's almost close to €5. So if you invest €1, it's €5. Sorry, $1,
wow.
$5, and that's
I'll take a 5x on my money.
Yeah, that's for the launcher. And if you look at Earth observation, and if you invest in an Earth observation satellite, so what we found is for at least for Europe, the European Space Agency, the return is close to €8 for Earth observation. And if you just put together everything, space on the whole, every euro invested in a space technology, the return is €10 to €12, depending on what application we are looking at. And this is the case for developed countries. I'm looking at Europe. That's the example for Europe. And I can only imagine, because I don't know if there were similar studies made for developing countries. I need to look if there was something done for India, where I come from, or for Africa or for Latin America. But I'm sure that the value is going to be double or triple than that, simply because of the opportunities that it's going to provide. The measurement is not just made by how much people are going to buy the services that use space technologies, but also it includes jobs that it generates. Jobs both for the building the satellite part, which is a lot of jobs, a lot of revenues, but also what we do with the data, right? Because we build software with the data and then we sell it, and that's again going to be scaling up very easily compared to anything else. And if you include all that, I think the return on investment from space in general is just even if you just look at it from Earth observation satellite, which Dr. Rabiu mentioned, as some African countries are investing in. I think that's one of the core reasons, because if you're a government or if you have a policy to invest millions of dollars in building satellites, you need to see the economic investment. And I don't think they would invest in space if they don't see the economic investment. And that's why you see so many countries going into space as well. And this applies for both Earth observation related programs, but also exploration. If you look at the return on investment for the Apollo program and why nations have started to invest or look at exploration, moon exploration, Mars exploration, or even just going to the ISS, there's a lot of economic return there. Some that are very, very tangible that you can measure, but some that will probably find out 20 years later through different cameras that we used for perhaps a Mars mission, and years later, then you'll find out that you can use that in hospitals, or you can use that for detecting different types of tumors within the human body. And these are not tangible benefits, so these are all more qualitative, not quantitative benefits. So it's interesting to look at both sides of the picture as well. It's not just about the numbers, but also on the qualitative side.
It's very, very interesting. Thank you, Dr. Mamondo. Did you have any? Could you perhaps comment on what you've seen in Israel and the surrounding regions?
Absolutely. I actually relate a lot to what Arvind said, and I specifically like the part where he said we can't all build the satellite.
Right.
And this is something that I explain to especially children, but not only, also adults. Once the satellite is in space, its work isn't done. That's where the fun parts begin, at least for me.
Right.
As an Earth observation scientist and a remote sensor. And one of the things that we are seeing in Israel is a lot of startup companies that are investing in satellite technologies. They don't need their own satellite. They could take the data from ESA or NASA or whatever. They don't necessarily use the data for Israel. They use it worldwide. But they develop the algorithms and the softwares. And we see that a lot in precise agriculture. And we see that, for example, in a company that is called Utilis, which actually uses radar images to detect leaky pipelines underground. Right. So you could do so many things with these satellite imageries that, as Arvind said, you invest. It seems like a really big investment, but you actually gain much more, because by using this satellite technology from remotely for a very large area, you're very, very benefited in the long term and even in the short term. And this takes a lot of human sources, manpower off. You're basically decreasing field work and all kinds of that you could rely on the satellite imagery. Zaire, I don't want to be rude, but as long as we have internet connection with Mishak, I think.
Mishak, yeah. No. Thank you. He just popped in. Yeah. Mishak, if you want to come off of mute while we've got you, can you comment on the applications that you're working on and that you've seen as a leader in the African Union? Please go ahead, sir, while we've got you.
Yeah. Many apologies for internet connection. That
we need Starlink.
That before me, totally agree with that. The applications the African Union were taking in terms of coordinating, harnessing all the activities in Africa. We are learning a lot of lessons from countries like Israel that has before me, many other, especially in Europe, have been able to combine many into a common. And we learned a lot of lessons when we were developing the strategy, the policy of our space program. And luckily now we have it focusing on Earth observation, satellite communication, navigation, and well as space science. Now, let's start by saying that I perceive space to be of three main segments. You have the ground and the system support missions. You have the space segment, what people, what is the hardware and the software that is sitting there in space, and then is that you have data applications and services. You ask me, one is the most important, and as a matter of everything is being designed with the end in mind, according to the user requirements, according to the user. And most of the times, these needs are in the applications or in the services, which is what connects the people. Now, having said that, I also want to add that as we are in the data economy era, there should be data accessibility, there should be data mobility and democratization of this data from satellites. And yes, as we have so much of free data available now, example in Earth observation, it doesn't translate to accessibility. And therefore, in my view, if the future.
Oh, looks like we lost him again. This is why we need Starlink, and we need it now. We need ground stations built in Africa to get satellite internet down to everybody. It's really simple equation, folks. So sorry, that's a case in point. I mean, the situation is making the case for the space economy in front of us. I want to shift gears a little bit, given that we've got about 20 minutes left here in our discussion. Thank you all for your amazing remarks so far. One thing that we haven't really addressed is how to enter the space economy as an individual. And I want to talk about that because it is very different around the world. It's very different growing up where I did in the San Francisco Bay Area, where it seems like everybody has a tech job and a startup or two. In fact, you're not even part of the economy, it seems, if you're not part of a startup, right? And then it's very different to my relatives in who are ethnic Indians in Africa or in India, who are managing farms or businesses or factories. Misha, glad we got you back. So how do people enter the space economy? And I want to toss this at Aravind to start us off, because you've talked a lot about in your podcasts about how to demystify space for people who may be intimidated by this, who may not be in a mindset about how they can participate. Right? The NASA stereotype of the white shirt with a black tie and a pocket protector shouldn't exist anymore. So what does somebody participating in the space economy look like? What do they know? What do they do? Where do they come from?
Yeah, no, it's a very interesting question, and it's been it's been a question that people have been asking me a lot, and just also from my background, I'm traditionally not from the space industry or quote unquote space industry, because I used to work in software for the first few years of my career, and then I made the jump into space about 5 years ago, and I've been working in the space industry ever since. And honestly, 5 years ago, I had no idea what the space industry was, and it took a bit of understanding and learning, knowing what my background is, and obviously, knowing what I know. Could I have been a rocket scientist? Probably not. And these are other things that you probably have or want to know what you want to do, and that's kind of the reason why I started the podcast. Is what did I have liked to know 5 years ago before entering the industry? Of different domains of space. What is space all about? And frankly, when I entered into the space industry, it was a bit overwhelming, right? It's like of course, you know about, like you mentioned, the NASA, which is the stereotypical space industry, and that's basically space. And you only equate that to space. But interestingly, whatever you do, you can kind of enter space and do the same thing within the space industry. If you're a software engineer, you can come into the space industry and code. You may need some fundamental knowledge if you are working on the software for the satellite. You probably need to understand how the satellite mechanism works. So you need to have some kind of technical knowledge. But then the language does not change. The way you code does not change. The Java is still Java, or whatever language that Python is still Python. And I'm sure that even for example, I'm sure Dr. Maman would agree that remote sensing, whatever it is, at the end of the day, you need to know the basics. But then when it comes to the foundation of how you build the product, you build it the same way like you would build any other software product in the world. So if you've got a full software background, which a lot of people in the world have today, it's one of the easiest ways to get into the industry. You just need to understand the foundations, and you need to put in the effort to understand whatever domain of space that interests you. It can be remote sensing, it can be satellites, it can be launchers and rockets, and even there's satellites, software, right? SpaceX's booster does not come automatically without a piece of software coded onto it. So at the end of the day, they're all software, and software is eating the world, as somebody in Silicon Valley said, and it also applies to
Mark
space. So,
Yeah,
exactly. Mark Anderson wrote that a few years ago, and it applies to the space industry as well. So that's what I tell people. Most of you can work in software, but it's also mean that you can also work in space. So that's the one example. And then there's the arts and humanities and other side of the equation, and there people have the fascination to get into the space industry. And I've met so many people in the space industry who do not have a background in space. They didn't study aeronautical engineering or aerospace engineering, but they are still designing habitats for Mars and Moon. And at the end of the day, you need to have an architect to kind of design the habitats. So you need to study architecture. Clearly, you don't want engineers to design the habitats, the ISS, it's not going to look pretty. So, that's where, you need to be an architect. And, again, the art side and the whole, of course, going to the business side of things, everything to do with business. And frankly, the space industry has a lot of technical people. And if you want to make space more commercial, you kind of need to have more business people coming in, people who can sell, people who can create new business models. And, again, some engineers are capable of doing that, like Elon, for instance, but then not all of them are Elon Musk. So you probably need some help from the business side of things. So there's, a lot of space for people who are business people, who are marketing people, sales people. So yeah, whatever the background, basically, I think there's, something to be done in the space economy. That's really it's kind of the cliche, but at the end of the day, that is the truth, because I've met people from so many different backgrounds that, I can't really say that this is the best knowledge, but what is important is, you need to put in the effort, because if you want to enter the space industry, you kind of need to define what's your area of interest: launchers, Earth observation, satellites, avionics, ground system, communications, whatever it is. You need to put in the work to understand the foundations of it. And I think that's kind of what is the most important bit, whatever your background.
Oh, thank you. I really, really appreciate that overview. Going from the technical to the non-technical or arenas of study. One thing that Israel has done clearly, and it seems like Africa is in the process of doing, is creating a space economy ready workforce. So I just want to open it up. Mishak, I don't know if while we've got you, I'd like to go to you. If you have any comments on what you've seen Africa doing, it's from the African Union perspective, or possibly even from your own country's perspective, on creating a space-ready workforce.
So much and I agree that you can space economy if workforce itself, and the continent has been. Do we actually build the capacity? In space. Complain that there is no infrastructure, but there is a significant level of infrastructure, as to the reflected that if we manage to have this infrastructure, we can have progress between countries who are far and those who are south in terms of technology, and build a as what we call the commerce of that need to support an African economy. Now, I think that a lot actually countries collaborate within themselves. A lot of South to cooperation current people training within Africa, countries exchanging their expertise. Good example, I think, project that there is KA, which is a kilometer array. We have in Africa that South Africa has been exchange programs. It's a good model, not enough because we have national collaboration, but it should be on a mutual engagement. Brain drain, yeah, not talking about gain, which is going these fellowships and having exchange that will later affect the continent positive. So I agree that models that are going on, the capacity development, critical measures that we are taking currently, what we call the Pan-African University Institute of Space, it's to be operational. So we need to have operation. It's South Africa to be able to have masters and PhD for countries in Africa. It's an organ of the union, and we not only initiatives that are being led by Africa, we are having initiatives that are being led by countries themselves, like Egypt, taking their own initiatives, capacity, individuals, and coming up to incorporate system development in Africa. We have maker spaces currently, so development of services, which is encouraged. So I would say that we have some level of growth in this decade, a lot of potential. We're going to have a lot of, even if it's not advanced or a robust program in the next few years, but we have to ensure that we have a good building base.
Thank you. I'd like to go to Dr. Maman to follow up on that. Those are amazing initiatives, particularly the fact that the programs in South Africa sponsored by the African Union will admit from all African nations. That type of collaboration across a continent is probably, it's unheard of. Asia doesn't do that. Europe does that at some level. The North or South America don't do that. So that's an amazing collaborative initiative. But one thing I wanted to ask though is to Dr. Maman is, having been kind of on the other side of that, having being in a country that's successful, looking back, what would you recommend to other developing nations that you feel were steps besides the clear culture of education that exists in Israel? Beyond that cultural aspect, what are specific things that you felt were very powerful in enabling that workforce development over the last couple decades that you've been in, involved?
I think that our personal experience shows that diversity is a key tool. Keeping everything very multidisciplinary, because as Arvind put it really nicely, you have the engineers, you have the architects. Usually they don't talk to each other. We found out especially that the engineers and the scientists usually don't talk to each other, and learning how to do that and to communicate the needs better to one each other brought us to this really great success. From our personal experience as well, and working force in Israel, we already start at the high school level. We have high school programs, both Duchifat and Tevel, which are students building nanosatellites in schools already. So we start as young as possible. We already have 3 nanosatellites launched by high school Israeli students, and another 8 to be launched really, really soon. They are already in the United States. So that brings a really great sense of achievement at a very young age. And by doing so, you're not only exposed to the engineering aspects, you're exposed to all the STEM aspects. And you study a bit of physics and math in order to calculate the thermodynamics or the orbits and everything you need. And everybody is working in a very multidisciplinary way that combines all of these together. And another thing that we're working on very strongly is the collaboration between the teams. Okay, so everybody has to learn how to collaborate better, which is, I think, a key tool for all space applications in general. I'm not talking just about specific issues, but this is something that would drive the space sector and will change the global space economy in the future. So these are the things that we've been working on.
Thank you, Dr. Maman. Professor Rabiu, I want to give it to you to finish us off here. We're coming up on the hour, and provide us with some closing comments. Given that you've seen 3 decades since your PhD was awarded, and hopefully, you'll see the next 3 decades as this moves forward. What makes you hopeful, and what makes you ready for what's going to happen next?
Yeah, thank you very much, Sahir. Actually, I'm excited, and it's a privilege for me to be in this dispensation. One of our strengths is the level of global cooperation that is going on. The international cooperation has made the space technology readily available in terms of applications and in terms of understanding that technology and the benefits that we can accrue from it. So, for example, today is a special day in our National Space Agency. We put on T-shirts that reflects the logo of our space agency. But the T-shirt I'm wearing is that of the South African, because I was there for a while, and I have their T-shirt. So what I'm wearing is South African Space Agency T-shirt. Now, the implication is this. There is, like as mentioned earlier on by my brother here, there is ongoing synergy, international cooperation, and between developed nations, advanced nations, and I think we should spend more time to propagate this global cooperation. And in doing that, we have a lot to benefit. We have a lot to spread around. And I think the future of the world lies in the way we utilize space technology and its application. That's what I'll say for now.
Well, thank you, Professor. And folks, we're at the top of the hour, or bottom of the hour, depending on which hour you're looking at. And I just want to thank, Dr. Maman, Professor Rabiu, Arvind, Mishak. Thank you all for your impressive remarks and comments. We've heard a lot of themes in the global trend. It's about applications. It's not just about getting there anymore. It's about what we're doing now that we're up there. And it's about what we're doing for life on Earth to make people's lives better. It's about how we're going to continue this amazing trend by making sure that our populations are ready. And that's inclusive, because it requires a truly diverse set of ideas and skills. And finally, I'll just echo Professor Rabiu in that the big trend, perhaps, and one that's very hopeful, is of collaboration conquering over competition. And that this is a human frontier that we can all benefit from. And if we go together, we'll go as far as who knows how far we'll go. There's literally no limit. It's bounded but infinite, as my cosmology professor used to say. So with that, I want to thank everyone for attending. I want to thank our speakers once again. Thank Anu and Shelley for organizing this spectacular event through Amplifying Her Voice. We are truly stronger together. The best to everyone around the world. Thank you, folks.
Thank you so much.
Thank you.
Thank you, Zahir, everyone.
Thank you, Michelle.
Thank you, everyone.